In this video, we're going to be looking at using substitution and elimination to solve nonlinear systems. So we're going to look at these three problems. So let's start with this first one. All right. So I'm going to be solving without a graphing calculator. So what I would do with this one is I see that it's pretty easy to eliminate the x. So what I'm thinking of doing is negating the first equation. So I'm going to multiply every term in the first equation by -1. And then taking this changed equation, new equation, and adding it to the original second equation. And making sure that everything lines up properly. So when I add these together, that's going to give me 14y squared, and those two will give me -140y. The x term is eliminated, and when I add these two terms together I get 0. So I have a new equation. Now the first thing I notice is that 140 is 14 times 10, so I can actually make this a little bit simpler if I divide every term by 14. And so when I do that, I'm left with this equation. Now that's easy to factor. They have a y in common, so I'm going to factor it out. So what will make this be equal to 0? Well, if y itself is 0, or if y is 10. Okay, so what happens if y is 0? Well, if y is 0, then I pick one of those top equations and I just substitute 0 back into it. Let's see if I can get it up like this. Okay, so if y is equal to 0, then if I plug in 0 for y into the top equation, that's going to give me this. And so that's just 0, and I'm left with x is equal to -7. So I get an intersection point, I get a solution. If you're writing your answer in point form, be very careful. Don't write 0, -7. That's not right. The x coordinate has to come first. So it's -7, 0. That's our solution. Be very careful about that. And then we also had that y was equal to 10. Well, what happens if y is equal to 10? Well, again, I'm going to plug that back into that first equation. So if y is equal to 10, I'm going to have 2 times 10 squared minus 20 times 10 plus x is equal to -7. So 2 times 10 squared is 100 times 2, so I'm getting 200 minus 200, so those go away, and x is equal to -7. So again, x is equal to -7, and again I have another solution. Remember, the x coordinate has to come first. So I have two solutions for this. I have -7, 0, and I have -7, 10. Okay. All right, so let's look at the next one. All right, what am I going to do with this fella? Okay, well, just looking at this, these will cancel out, these two terms, the x terms will cancel out. So again, I could subtract the two equations. I could multiply one of them by -1. So I think what I did here was I multiplied the first equation by -1. So I just negated every term in the first equation. That's what multiplying by -1 equals. And then I'm going to put the original second equation underneath it. Notice I've left some spacing there because this equation didn't have a y squared term. And now I want to add these two equations like they are. And so when I do that, these will cancel, those will cancel. I don't have any y squared term, so I just get 17y squared, and then 12y plus -148y, or 12y minus 148y gives me that, and then these two added together give me that. I want this all to be equal to 0, so I'm going to subtract 153 from both sides. Now, it would really be nice if this first term was just y squared, if they had something in common. I don't know the factors of 17, but I'm really hoping that these are divisible by 17. Let's just see. What's 136 divided by 17? Hey, it's 8. And what about 153? It's wonderful. 8 and 9. Okay, so what I'm going to do here is I'm going to make this easier. I'm going to divide every term by 17 because 17 is a factor of everything here. Of course, 0 divided by 17 is just 17. So I'm going to have y squared minus 8y minus 9 equals 0. That is easy to factor. Two numbers that multiply together to give you negative 9, but at the same time they add up together to give you negative 8. Negative 9 and positive 1. So that's how I will factor it. And then once it's in factored form, it's easy to see what will make this 0. And so now let's check this. If y is equal to 9, then what I'm going to do is I'm going to take the top equation. So I've written that down here. I'm going to take that top equation, and I'm going to plug in y equals 9 into the top equation. So I have my x terms, and I have minus 12 times 9 equals negative 108. And so then that gives me this, and these will cancel. And so I just have that that's equal to 0. And now I can factor out a 5, and I can factor out an x. And so when I factor that out, I have that. When it's in factored form, it's easy to solve. I'll either have, what will make this 0? Well, if x itself is 0, or if x is negative 10. So again, when you're writing your solutions here, be very careful. The x term has to come first. So it's 0, 9, not 9, 0, that would be wrong, and negative 10, 9. But we're not done yet. I have to look at the case, what happens when y is equal to negative 1. Okay. Well, if y is equal to negative 1, then again, I'm going to select the first equation because it's shorter, and I'm going to plug in negative 1 for y. And of course, that'll give me positive 12. And then when I add 108 to both sides, I get that. And every term here is divisible by 5. So I'm just going to divide everything by 5. And so I'm going to be left with x squared plus 10x plus 24 equals 0. Again, that is easy to factor. Two numbers that multiply together to give me positive 24, but at the same time add up together to give me 10. Well, 4 and 6 will do that, so I can factor that. When it's in factored form, it's easy to see how it, what the solutions are. What will make this 0? Well, if x is negative 4 and if x is negative 6. Okay, so be very careful. You got to write the x coordinate first. So I'll have negative 4, comma, negative 1, and I'll have negative 6, comma, negative 1. And so in total, we have 4 solutions. And that's our 4 intersection points. And so that's what they are. And then my last example is we want to solve this. Now notice to this one, they're both equal to y. They're both equal to the same thing, so you could put them just equal to each other and then get everything over to 0. That's one way to do it. Another way to do it is you could take these two equations and subtract them. So that's what I did. Let's subtract these equations. So I'll have y minus y, which will give me 0. I'll have 2x squared minus nothing there, so I get 2x squared. I'll have negative 3x minus negative 5x, so negative 3x plus 5x, which gives me 2x. And then I'll have negative 1 minus 3, which will give me negative 4. Now, notice there that every term is divisible by 2. So I'm just going to divide 2 out of everything. And that's going to leave me with this, which is easy to factor. And so the solutions to this are x is negative 2 and x is 1. Well, if x is negative 2, then I'm going to come back up here and plug negative 2 into this equation. And I get y is 13, so I get a solution. And if x is 1, I go back up to this equation and plug in 1, and I get a solution there. And be careful, so I'll have that. So we have 2 solutions for that. And that finishes this video.